Hello, ladies and gentlemen. So now I want to talk to you about geometric sequences, and in this first video, I'm going to give a very brief introduction to what they are. Okay. So a geometric sequence is a sequence which has some non-zero initial term, and whose successive terms are formed from those before my multiplication with the same number. A number we will call the common ratio. Okay. Not the same number that we started with, but some number. Okay. So for example, let's say I take okay. So let's say I have 2 being the first number in my sequence. And let's say that I multiply it by 2. I get 4. And let's say I multiply that by 2. I get 8. I multiply again by 2. 16. So you can see that this would actually be a geometric sequence, because each time I'm multiplying by the same number. It just so happens that in this case it's 2. Let's try an example, like let's say I start with 3. Let's say I multiply it by 1/3. If I multiply 3 by 1/3, I get 1. If I multiply 1 by 1/3, I get 1/3. If I multiply 1/3 by 1/3, I get 1/9. This is also a geometric sequence. And in this case, the common ratio would be 1/3. What if I have the sequence 5? Let's say 4. Let's say 3, 2, 1. Is this a geometric sequence? Let's find out. 5 times 4/5 would give me 4. What would be 4 times 4/5? That would be 16/5. 16 divided by 5 is not 3, even though it's close. So we can immediately see that this is not a geometric sequence. In fact, you can see that I'm subtracting 1 each time, so this is actually an arithmetic sequence, right? Of course, later we'll look at it more carefully. We'll look at a more systematic way we can find out if it's a geometric sequence. But so this one is not a geometric sequence, and these ones are geometric sequences, okay? The key point is that we're going to multiply the initial term by some number, and we're going to multiply it by some number, which we call the common ratio, and we're going to multiply, so that'll be, in this case, like 2, and then that same number will be used to multiply this term to get the next term, times 2. You see, this is the initial term, times 2 is 4, times 2 is 8, times 2 is 16, and that's how we're going to generate the whole thing. This one, I'm multiplying it by 1/3, multiplying by 1/3, multiplying by 1/3, and so on to generate the geometric sequence. The reason, and of course you can already see here, why did it have to be a non-zero initial term? If this term was 0, then if we multiply it by anything, the next term will be 0, 2, the next term will be 0, 2, and that's not really interesting, okay? With that behind us, let us now move on to see a more substantive example and to make some observations.